There we go. Now I'm recording. And we want to work on 3 cosine theta plus 1. This graph right here. And so remember what we said about graphing these draw. Cosine theta plus 1. All right, so remember what we said about what's the main approach to graphing these polar graphs in polar coordinates? What do we say? Anybody remember? It's a long weekend, I guess.
Make a rectangular.
Right, so we're gonna do that. We're gonna graph that same graph in rectangular coordinates. R is a function of theta. So we're gonna put R on the vertical axis, theta on the horizontal axis. So it's just cosine theta that has a period of 2 pi before it starts over. So we'll take whatever the period is and break it into fourths. Okay, and so then we look at this and we say, what's the midline, the max, and the min? So what's the midline of this graph, 3 cosine theta plus 1?
Is it y equals 1?
Yeah, so we know the midline of just cosine is 0, and now everything's moved up 1. So our midline will be 1. And then what will the max and the min be? So what will the max be? If the amplitude is 3,
4.
it'll be 4, right? So this, we know the amplitude of cosine is 1, times 3 makes it 3, add 1 is 4, and then what's the min going to be? Is that Naven? You're really quiet, Naven. I can barely hear you.
-2.
Yeah, there you go. -2. Right, so we're going to go up 3 and down 3 from 1, which makes our midline, or min -2. And so cosine starts at where does it start at the min, the midline, or the max? Cosine.
Starts at the max.
At the max, right? Cosine is 0 is the maximum value. It's the maximum x coordinate. Cosine is x coordinate. And so add 0 is max. So that's going to be 4. Okay, and then it can only go down from there to the midline. And it keeps going down to the min, back to the midline, back to the max. That's the best cosine curve I've drawn all day. Okay, and so now we're going to use that. We're going to use that graph to help us do the polar graph. So what's going to happen? So at theta equals 0, our value of r is what?
4.
Value of r is 4. And so as we go from 0, what? 0 to pi over 2, that value of r is going to go from what to what?
To 0.
To 1, right? It goes to the midline, which is 1. And that's at pi over 2. So let's write that down. Okay, so, and then will it start, how will it go from 4 to 1? Will it start slowly, start quickly?
It'll start slowly and then speed up.
Right, so we'll start at 4, and imagine the point starting here at 4, so 1, 2, 3, 4, we're going to start here. Now imagine in your mind's eye, what? As theta increases, as we go around counterclockwise, that we're going to slowly decrease at first, and then as we get closer to pi over 2, that radius, that r value is going to more quickly decrease to 1. So imagine that we're at 4, and imagine the radius slowly decreasing, and then more and more quickly decreasing until it ends up at 1 when we're at pi over 2. So can you imagine what that looks like? I'll turn the dot on, and we'll see. So there it is at 4. And so as theta increases, going down slowly, look at that. So r is just creeping down slowly. But now in the second half, r is going down more quickly. Actually, let's just do a play. Look, notice R is still hovering very close to 4, going down very slowly as theta increases. But then as theta increases more, now R starts to more rapidly head down. And now R is even more rapidly until we get close to pi over 2. And now R is decreasing the most rapidly until it reaches 1. Well, gee whiz. Okay, so what does that look like? So that will look like this. Decreases slowly. Decreases, gee whiz. So R decreases slowly at first. And then decreases rapidly, getting closer to 1. Or what about from pi over 2 to pi? So R will continue to decrease rapidly until somewhere we're going to reach the pole. So we're going to keep increasing theta, going around counterclockwise, and somewhere there, closer to pi over 2, we're going to reach the pole. And that's that angle right there. So whatever this angle is right here, whatever angle we got right there, that's where R is 0, and it's past pi over 2, and we're at the pole right there. And what's going to happen after that? As we continue on to pi, what's the value of R going to do? It's going to go from 0 to what? 0 to negative 2. So when we get to pi, pi is this way, right? This is pi. And so we'll be at negative 2. That means the rest of the way here in the second quadrant, where's the graph going to be? In which quadrant? Negative R values.
The fourth quadrant.
Fourth quadrant, right? So what will that look like? Decreasing rapidly, right? So notice it's going increasing negative, heading down the red. Uh-oh. Okay. Heading down the red part of the axis. This means decreasing and getting more and more negative. Then it's going to, in terms of the amount, the decrease is going to slow down until we get to negative 2. Right? So here's keeps decreasing rapidly and then decreasing more slowly, so that we see that's hovering closer to negative 2 here as theta increases. All right, any questions on that so far? So R goes from 4 to 0 slowly at first, then more rapidly, and 0 is some angle measure past pi over 2, this angle measure here. And then after that, R keeps decreasing, getting more negative, until we reach pi, and we're at negative 2 at pi. And then it's going to, it looks like, so by symmetry, it's going to undo what it did, right? So then now from pi to some angle shy of 3 pi over 2, it's going to increase back to 0. So what quadrant will that graph in? Right there?
The first quadrant?
Right. So if positive R values are in the third quadrant and our R values are negative, that's going to graph along the red axis, which will be in the first quadrant, even though those third quadrant angles. And it's going to increase slowly at first, and then more rapidly till we get to 0, and that's just shy of 3 pi over 2 here. And now R is gonna increase from 0 back to 4, quickly at first, and then slowly. Right? So watch the point. It's gonna shoot out. It's shooting out quickly. See that? How the R value shoots out quickly as theta increases. And now R is increasing more slowly, close to 2 pi. Okay, so you're gonna have practice in your written homework doing these. So you won't have the software to do it. So you really gotta practice in your imagination this idea of how does R change as theta changes, right? Theta is sweeping counterclockwise, and R is either increasing or decreasing, and either quickly or slowly. Let's come up with a graph. Any questions on this one?
Can you go over the transition from pi to 3 pi over 2 again?
Yeah.
Where we go from r is -2 to 1. Thank you.
So here we are at -2. And so what does this graph tell us up here? This graph tells us up here that we're going to increase from -2 back to 0 as we turn through these angles here, right? So we're turning through like these angles here, like this.
Mm-hmm.
And we're going to increase from -2 back to 0. And that's going to be slowly at first. So increase, so going counterclockwise. Increasing slowly means kind of staying close to -2, like this. So you can imagine angles like this. Good. That. So increasing slowly at first, getting less negative until we get somewhere down here. We're going to hit 0. Hit 0. And so now it's starting to decrease more rapidly, and then we're going to get to 0. At some angle measure shy of 3 pi over 2, we're going to be back at 0. And then from that angle measure to 3 pi over 2, now we're in positive territory, and we're shooting up quickly to 1. So that's from here to here. It's going to shoot up quickly to 1. Did that help?
Yeah, a lot.
Okay,
Thank you
good.
so much.
And let's do the pretty version of that again. So here we go. So R increasing from -2 to 0, which means across in the first. Wow, I just can't escape this. So here it is, increasing, getting less negative as theta increases through the third quadrant. Now it's going to increase faster. So we're heading towards the pole more quickly until we reach 0. R equals 0 is right about here now. And now R is shooting up quickly to 1 when we get to 3 pi over 2. And then from 3 pi over 2 to 2 pi, R increases from 1 to 4. Quickly at first. And then slowly at the end. All right, let's try another example. Let's do 5 sine 2 theta. So we're going to do the graph of 5 sine 2 theta. Okay, so let's try this one. So what we're going to do first, we're going to graph it in Cartesian coordinates. So what's the midline? Or let's do the period first. So what's the period of this? Well, now we've got our argument is not just theta. So we know that we get a full period when the argument reaches 2 pi, right? So when this thing in parentheses reaches 2 pi, that's when we finish a full cycle. So what is that for theta then? What value of theta makes this thing 2 pi?
Pi.
Pi. So we're going to get a full we're going to get a full cycle of sine when theta reaches pi. So dividing it up into 4 now, we got pi over 2 and pi over 4. And 3 pi over 4. So that's going to be our full cycle of sine of 2 theta will be at theta equals pi. Because theta equals pi makes this thing 2 pi, and we finish our cycle. All right, what's the midline is 0, the max is 5, the min is -5, and sine starts where? Max, midline, or mid? Min?
Midline.
Midline, and goes positive sine goes up. Okay, so and then if we need to, we'll see how the polar graph is going. We might need more cycles here, so we could keep going if we need to. We'll see. All right, and that would be 2 pi. So 2 pi would give us 2 full cycles because of the 2 there. All right, here we go. So let's graph this. Imagine what's going to happen. So from 0 to pi over 4, what's r going to do?
Go from 0 to 5.
0 to 5. All right, and so that's a big change in r for a small change in angle, and it's going to shoot rapidly at first and then slow at the end. So at pi over 4, we're going to be at 5. That's here. 1, 2, 3, 4. We're going to be here. By the time we get to pi over 4, we're going to be at 5. So it's going to shoot out rapidly at first. It's going to shoot out rapidly at first, and then more slowly when we get close to pi over 4. So imagine what that's going to look like. Watch it. Here we go. Shooting out rapidly at first, and then slowly, right? And then slowly. Okay, and then from pi over 4 to pi over 2, slowly decreasing, and then rapidly decreasing back to 0 at pi over 2. So by the time we get to pi over 2, which is here, we're going to be back to 0, back to the pole. So that's going to kind of undo what it did in the first pi over 4. So it's going to watch the point, and then head back slowly, a little bit, kind of more slowly at first, and then rapidly back to 0. So that's going to make like a pedal, right? It's going to make like a, let's see it. So heading out rapidly, right? Heading up, r is increasing rapidly until we reach pi over 4. And now it's kind of a little more, r is changing a little more slowly, hovering by pi over 4. And then it's going to start to decrease slowly. And then as theta continues to increase, r is going to decrease rapidly. Okay, so now from pi over 2 to 3 pi over 4, which is out to here, what's going to happen? R is going to go from what to what?
0 to -5.
0 to -5. So where will that graph?
In the 4th quadrant.
Right. In the 4th quadrant. And so by the time we get to pi over 4, 3 pi over 4, which is here, we're going to be at -5. So 1, 2, 3, 4, 5. So it's going to decrease rapidly, get more and more negative until we get to 3 pi over 4. And we're going to be at -5 when we get there. So here, so we're turning counterclockwise in the 2nd quadrant. Our values are negative. So we're going to graph in the 4th quadrant. So getting more negative or decreasing rapidly to -5 at 3 pi over 4. And then from 3 pi over 4 to pi, from -5 back to 0. So as we go through these angles here, we'll start at -5. And our r will decrease back to 0 by the time we get to pi. So that'll just finish out that leaf. So increasing slowly at first, now increasing rapidly, so you get to pi. Where you're back to 0. R is 0. Okay, so it looks like we do need another cycle here of the Cartesian graph out to 2 pi. This is 3 pi over 2. So now we're going to get the same positive R values that we got in the first quadrant out to 5, back to 0. That we got. That's the same thing that happened in the first quadrant. Positive R territory. Out to 5, back to 0. And now we're at 3 pi over 2, and the same thing's going to happen that happened when we were in the second quadrant angles. Now we have these fourth quadrant angles, have these negative R values. So we're going to go from 0 to negative 5. And now our angle is here at 7 pi over 4. And we're at negative 5. And now we're going to increase back from negative 5 back to 0 as theta goes from 7 pi over 4 to 2 pi. And now it starts over. So the period, we talked about this before, the period of the Cartesian graph can be different or the same as the period of the polar graph. In this case, we need 2 cycles of our graph, Cartesian graph, to get the 1 full cycle of the polar graph. So here the period is 2 pi, whereas the period for this is 2 pi. We have to do 2 cycles of our Cartesian graph to get the full period of the polar graph. Okay, questions? Again, so I hope you're really like tuning in and trying to do this, because you won't have the software and my explanations when you're doing this. You have to it's really about a lot of imagination. As theta increases, as you go counterclockwise, how is that point being generated on that R axis? Any questions? All right, let's do another one. 2 cosine theta plus 2. Let's do 2 cosine theta plus 2. Or why don't you take, see if you, so that's the, so f of, next one we'll do is f theta equals 2 cosine theta plus 2. We'll graph it in Cartesian together, and then you do the polar graph without any technology. All right, so what's the midline? 2. And what's the max and the min? So our amplitude is 2. Our midline is 2. That makes the minimum what?
Minimum would be 0.
0, and the maximum would be? 4, right? So 2 up from the midline, 2 down from the midline means 0 to 4. Cosine starts at? The max, goes to the midline, down to the min, back to the midline, up to the max. And our period is just 2 pi. So 2 pi, 3 pi over 2, pi over 2. Okay, so now use this Cartesian graph to see if you can sketch. This is an easier one. There's no negative. We have no negative R values. So without any technology, see if you can, in 2 or 3 minutes, if you can sketch that polar graph. Ready? Go. Okay, so from 0 to pi over 2, what does R do?
It goes from 4 to 2.
4 to 2. And it's going to go, it's going to slowly at first. So R is going to decrease slowly at first. But then when we get closer to pi over 2, R is going to decrease more rapidly until we reach 2 at pi over 2. So slow decrease. We know that means it's going to stay close to 4. But then more rapid increase until we reach pi over 2 where we get to 2. So that looks like this. Slow decrease of r, and then faster decrease of r. Okay, and then from pi over 2 to pi, r is going to go from what to what?
From 2, 0, starting quickly and slowing down.
Yeah, right. So it's gonna rapidly decrease as theta increases, and then it's gonna kind of slow down a little bit as we get closer to pi, when it's gonna get to 0. So rapid decrease, and then slow decrease, and then when we reach pi, we're at the pole. And then from pi to 3 pi over 2, what happens to r? It's going to increase again from 0 to 2. Slowly at first, then rapidly until we reach this point here. That's 3 pi over 2, 3 pi over 2. So slow or rapid increase. Sorry, slow increase. And then rapid increase closer to 3 pi over 2 until we reach 2. And then from 3 pi over 2, it's going to go from 2 to 4. And it's going to go rapidly at first, right? High rate of change, and then slower rate of change. So it's going to shoot out away quickly. R value is increasing quickly, and then R value is increasing more slowly until you reach 4 at 2 pi. Any questions on this, making this graph? And hopefully there was many of you were able to do that before I did. Okay, so I'm interested in the highest point. I want to find around here the highest point. Somewhere there is the highest point. So what would characterize, if I think about calculus, what would characterize the highest point?
A slope of 0.
Okay, I heard a slope of 0. So dy dx equals 0. Okay, so our function is r as a function of theta. Is it going to be convenient to find dy dx? Is there another way we could find the highest point?
dr d theta.
dr d theta. So dr d theta. What is dr d theta at that highest point? So somewhere around here. What is dr d theta?
It's negative.
Is it 0? Someone said negative. Right, because so as theta increases through here, what is r doing? Isn't r decreasing, right? So as we go through there, we're getting closer to the pole. So dr d theta at that highest point is negative. Is that so dr d theta going to help us find that highest point? No, because we don't know what value it is, right? It might if we knew exactly what negative value it was at the highest point, but we don't know. We don't know what the negative rate, that rate of change is. It's just some negative value. So we need, at the highest point, this is the key, that y is not changing, right? Y doesn't change at the highest point. But our function is in terms of theta. So what would be another way to find that highest point? We need y to not change, but our function is in terms of theta. So what could help us? So what about dy d theta equals 0? As for a little change in theta, we want y to stay constant. So now we're kind of like overlapping the two systems, the two coordinate systems. We're combining rectangular and polar coordinates, which is fair. We can do that. So we're saying as theta increases through here, we want the y value to not change. So this is what's going to do it for us. So how are we going to, from what are we going to find dy d theta? I have r as a function of theta. I would need y as a function of theta. What is y as a function of theta?
R sine theta.
Right. Isn't y always r sine theta? And what is my r?
2 cosine theta plus 2.
Right, so we only care about the points on the blue graph, and that's this. So on the blue graph, r is 2 cosine theta plus 2. So 2 cosine theta, 2 cosine theta plus 2, the quantity 2 cosine theta plus 2 times sine theta, gives me all the y values on this graph as a function of theta. And I can use that to do dy d theta equals 0. So before we plug in the 2 cosine theta plus 2, let's just, so you're going to use r as a function of theta, sine theta. Let's find dy d theta generically for any r as a function of theta. So how am I going to find dy d theta if it's always equal to r sine theta, r of theta times sine theta? How do I find the rate of change of that? Product rule, right? I have two functions of theta, so I use the product rule. So we can do the first times the derivative of the second plus the derivative of the first times the second. So there's my dy d theta. For all polar functions, dy d theta will be r of theta times cosine theta plus r prime of theta times sine theta. So now for our particular graph, we can write out what it is. R of theta is 2 cosine theta plus 2. And what's r prime of theta? R prime will be negative 2 sine theta. That'll be the derivative of that. And that's my dy d theta. And if I'm looking for the highest point, what do I want with this?
Equal to 0.
Right, at the highest point, for a change in theta, as theta increases, we want y not to increase, y to stay constant. So we're going to set that equal to 0. All right, I'll pause there for any questions. Did you follow everything? Since y is r sine theta, and we want dy d theta, we use the product rule. This is the generic formula for dy d theta for any polar graph. R theta is 2 cosine theta plus 2, which makes r prime negative 2 sine theta. And so there's the product rule for our particular graph here. So now I have to solve this thing. I'm going to just write c for cosine and s for sine for times and writing sake. So 2 cosine squared theta plus 2 cosine theta minus 2 sine squared theta. And if you remember from your pre-calculus, this is like a quadratic of cosines and sines. So we got to get it written all in cosine or all in sine. So since we got cosine here, let's change this to cosine. So we can use the Pythagorean identity. What is sine squared equal to?
1 minus cosine squared.
1 minus cosine squared. So I'm going to plug that in, and then now I've got everything in terms of cosine. So I'm going to have, there's 2 cosine squared plus another 2 cosine squared. So that's 4 cosine squared. And then I got plus 2 cosine theta minus 2. And that since this is going to be equal to 0, since we make this equal to 0, I can divide by 2, and I get 2 cosine squared plus cosine theta minus 1 equals 0. And so this is a quadratic. It's just like 2x squared plus x minus 1. So can it factor? So I got negative, I got to multiply to -1 and add to +1. Can I do that? So I need a -1 and a +1, and then the inner and outer terms have to add up to positive cosine. So I think I would do -1 because minus cosine, and then +1 because +2 cosine. That makes +1 cosine. So this means that cosine theta is 1/2, or cosine theta is -1. Awfully quiet out there. Is everyone following me?
Yeah.
Yep.
Yeah.
All right, so now you just have to know your unit circle. Where is cosine theta? Where's the x-coordinate positive 1/2 on the unit circle? Well, that's at pi/3, but then also at, in the fourth quadrant, 5pi/3. Where's cosine theta equals -1? That's at pi. So there are actually 3 places between 0 and 2 pi where we're horizontal. dy d theta equals 0, meaning as theta increases, your y doesn't change. So pi/3, well, that sure looks like this highest point. This is our angle pi/3 right here. So it actually ends, the highest point is actually right there on that key angle, theta equals pi/3. And then at pi, so what's happening here? As we come in like this, so as we get to pi, it's coming in and it's going to be right at the pole, it's going to flatten out and be horizontal. And then shoot out horizontal the other way too. So you have a horizontal tangent right there at pi. And then 5pi/3 is the same spot down here at the bottom. Again, horizontal tangent. As theta increases, y doesn't go up or down. That would be like a local minimum. And then we can find the, how do we know that at pi/3 we got the highest point. So how could we find the r value and the highest y? How could we find both of those?
Can't we plug those points in for theta into the equation that equals r?
Yeah, if you want the r value for theta, that's what your function gives you. It gives you the r value for every theta. So you plug pi/3 in here, it'll give you the r, how far out from the pole you are. And then if you plug pi/3 into the y equation, take that r value and then multiply it by sine of pi/3, you'll get the y, the maximum y value. Okay, now I want to know, so right here, the graph goes to the, at pi/2, we can imagine there's a tangent line right there. I want to write the equation of that tangent line. So does it make more sense to write that equation of that tangent line in terms of y and x, or in terms of r and theta? Which makes more sense?
Y and X.
Y and x, right? Lines, slanted lines don't fit well with polar coordinates, right? But they fit very well with rectangular coordinates. So I want to write this as a function of x. And so what do I need for that? I'm going to need dy dx and the y-intercept, or some point on the line. Well, the easy point would be to get the xy when what? When x is 0. So if I could get dy dx and the y-coordinate of this point when x is 0, like the y-intercept, then I could write the equation of this line. How am I going to get dy dx?
Do you do dy d theta divided by dx d theta?
Yeah, good. So we saw this with parametric equations, right? dy dt over dr dt. Well, now we can do dy d theta over dx d theta. We already have dy d theta. That was this right here, 2 cosine squared plus 2 cosine minus 2 sine squared. So how would we get dx d theta?
x equals r cosine of theta, and so then we plug in our r equals into that.
That's right. So we're going to have so x equals r cosine theta. So dx d theta is r of theta, what, negative sine theta plus r prime of theta cosine theta by the product rule. And so for our function it'll be 2 cosine theta plus 2 times negative sine theta plus negative sine theta, the derivative of 2 cosine theta plus 2 times cosine theta. And so then I've got it. I've got 2 cosine dy d theta is 2 cosine squared theta plus 2 cosine theta minus 2 sine squared theta.
Professor?
Yeah.
Shouldn't it be negative 2 sine theta for dx d theta?
R times plus negative, I think I have this right. It says R is 2 cosine theta plus 2 plus the derivative of cosine is negative sine plus R prime is negative 2. Negative 2 sine, is that what you're saying?
Yeah.
Is that what you're saying? Right, okay, so negative's good.
Yep.
Negative 2 sine theta and cosine. So we're going to get, it looks like negative 4 cosine theta sine theta minus 2 sine theta. And that would be our dy dx as a function of theta. So what are we going to plug into that to get the slope of this line? To get dy dx, we'll do what?
Get a value of theta.
What value of theta?
Pi over 2.
Pi over 2. Because we want, right here, we want it at pi over 2. So we're going to plug in pi over 2. We're going to get a value. That will be dy dx for that line. What if a different question, what if I had dx d theta equal to 0? What if I set dx d theta equal to 0 and solved it? What would values of dx d theta equal to 0 represent on the graph?
That would be leftmost or rightmost points.
Good, vertical tangents, right? So leftmost points or rightmost points where the graph goes vertical. So we would expect 3. We'd expect theta equals 0 where dx d theta is 0. And we'd expect 2 more angles, one here in the second quadrant and one here in the third quadrant where dx d theta is 0.